Welcome. In this lecture, we will see types of a DCV. As we know, DCV stands for Direction Control Valve. So, various direction control valves are used in a hydraulic and pneumatic application. These are classified as given below. Yes, so there are two categories. According to the method of actuation, there are few types, and according to the types of spool, and also according to the number of ports and position. So these are the classification of a direction control valve. In the method actuation, these are classified into a manually operated, pilot operated, and the solenoid operated. Manual operated consists of a manual interference either by a palm, by a push button type, or a hand lever, foot pedal, or a cam operated. Yes, cam and rotor operated. In a pilot operation, there can be a single pilot and a double pilot. Pilot operated means external fluid supply is controlling the operation of a direction control valve. That is pilot operated. Yes, single pilot means in a single direction it is controlling the motion. Reverse direction takes place with the help of a spring. In a double pilot, both the direction, external pump or a fluid is controlling the motion. Similarly, solenoid is also classified into two types. One is the single solenoid and another one is the double solenoid. In a single solenoid, it is controlling. Solenoid means now electromagnet is used for the operation. Yes, in a single solenoid, forward motion is controlled by the electromagnet, which is created by the electricity, and reverse motion is controlled by again spring. In a double solenoid, both the direction it is controlled by the electromagnet. According to spool type, yes, it is classified into a puppet type. Yes, conical puppet is generally used. Then sliding spool type, yes, rectangular spool is there, or a rotary spool is there. So according to the spool, to close the supply, these type of a spool are used in a direction control valve. So these are the classification. According to the number of ports, these are classified into a check valve. Check valve consists of a two port, then 2 by 2 DCV, then 3 by 2 DCV, 4 by 2, 4 by 3, 5 by 2, etc. So we are going to see all these in detail. So we will see first thing. First one is the check valve. Check valve is also called as a unidirectional valve. Yes, check valve is also called as a unidirectional valve. Why it is called as unidirectional valve? Because it controls the direction of a flow in a single direction. The reverse flow is a not possible in case of a this check valve. Yes, so here if we see, it is having a flow from the, it is allowing the flow from the A side to B side. Yes, now here ball is there, ball seat is there. Yes, spring is there. Spring is making the ball to have a continuously in a position of a seat. So there is no flow at all. But if there is a flow occurring, then this flow is pushing this ball towards the right side by compressing the spring, and there is a flow occurring in the forward direction, or from A to B we can say. But if we consider the reverse flow, now this is the second condition. If we consider the reverse flow, then this reverse flow is making ball not to lose any fluid from B direction to A direction. So there is no flow in this direction. This is the working of a check valve. If we see the symbol, then symbol also says that there is a flow from A to B. Yes, this is the A and this one is the B, A to B. But if I am giving the supply from B port, then it is not allowing the flow in a reverse direction. This is the check valve. It is generally used in a footwall of a centrifugal pump, and there are many applications of a check valve we are going to see in the various circuits. Next valve is the 2 by 2 DCV. Now here 2 by 2. Now this first 2 represent the number of port. How many number of ports are there? Now here 2 ports are there. A port and the B port. And second number represent the number of position. This one is the position number 1 and this is the position number 2. Now on the left hand side we are having a sliding spool type of a valve, and on the right hand side we are having a rotating spool type of a valve. Working is the same, but depending upon the application we either prefer rotary or a sliding type of a direction control valve. If you see the symbol also, symbol consists of now 2 ports. One A port is there, B port is there. Same thing, A port and the B port. And position are also 2. Position number 1, yes, and position number 2. Yes. This is the spring return push button type of a symbol. So this how it works. If we consider the position number 1, in a position number 1, this spool is at this central location. Now, this spool does not allow the flow of a fluid from A towards the B. So this is the position number 1. Here in a symbol also you can see this fluid does not allow flow of a fluid from the port A towards the port B. So there is no flow. If I am pressing this push button, then what will happen? This spool will compress the spring. This spool will compress the spring and the flow between port A and B will get established. So there is a flow from the port A to B. Same condition. Port A to B supply is there. Same thing is valid for this rotary type of a 2 by 2 DCV also. In a first position, this is the first position, this is the second position. What will happen? Here in a first position, port A is there, 2 ports, inlet port, outlet port. So 2 ports are there, 2 position. This is the position number 1, this is the position number 2. So same symbol is there. In a position number 1, A port is not connected to a B. So there is no supply from A to B. But if I rotate this spool, yes, we are having arrangement for rotating the spool, rotary spool. So if I am rotating the spool, then the connection between the inlet port A and the port B get established and there is a flow of fluid from A to B. So this is the working of a 2 by 2 direction control valve. If you understand this working, then subsequent direction control valve workings are similar to this. Only there is a changes in a number of port and number of position. So we will move forward. Now this one is the 3 by 2 DCV. In a 3 by 2 DCV, there are 2 position. There are 2 position, but now here ports are 3. Here A port is there, P stands for pump, and T port is the T stands for tank port. So there are 3 port and the 2 position. Here I can give the nomenclature. Position number 1, here position number 2. There are 3 port, P, T, A. Here P, T and the A port. So what happened in a position number 1? Now this give the name as a position number 1, position number 2. Okay, so this is the position number 2. First we will see the sliding type, then we will see the rotary type. In a position number 1, port A is connected to a pump. Yes, so fluid supply will take place from the pump to port A. Now, if I am pulling this lever, yes, if I am releasing this lever, so spring get uncompressed and the spool will come, sliding spool will come at this position. In this position, now supply connection between P and A is disabled. There is no connection between the pump and the A port, but the connection between the port A and the tank get established. Okay, so this is the condition. If I am yes in a first position, P is connected to A. Yes, T is not connected nowhere. T is connected nowhere. But in a second position, pump is connected nowhere, but A is connected to T. If we see for the rotary type, same thing is valid in a first position. This one is the first position and see this one is the second position. Okay, in a first position, A port is connected to a P and T is connected nowhere. And in a second position, pump is not connected, but A port is connected to a tank. A port is connected to a tank. So this is the working of a 3x2 direction control. Now, next one is the 4x2. In a 4x2, there are 4 ports. For wide application, this 4x2 port is used and 2 position. Yes, so this is the position number 1 and position number 2. Here you can see position number 1 and position number 2. And this condition, yes, same thing. All other construction is same. Now, in the first position, A is connected to a pump. A is connected to a pump and B is connected to a tank. B is connected to a tank. So this is the first condition. Now if I push this button, okay, if I push this button, then different connection get established. A get connected towards the tank. A get connected towards the tank. Here this is the A and this port is the T port. Okay, A get connected to a tank port and P get connected to a B port. When we see the working in case of a meter in meter out circuit, at that time we will come to know that how this is helpful in controlling the direction. Okay, so this is the condition. In the case number 1, A is connected to P and B is connected to T, and at position number 2, A is connected to a tank and P is connected to a B port. Same thing is valid for the rotary type also. Okay, in a position number 1, A is connected to a P, okay, and B is connected to a tank. If I rotate this rotary spool, then what will happen? The connection between A and T get established and P and B get established. Okay, so this is the working of a 4x2 DCV. So we will see other function in a next lecture, other DCV in a next lecture.